It is late. You know the vibe. Your IDE is set to dark mode. The glow of the monitor is basically the only light in the room, and you are just staring at a loop.
Oh, yeah, we have all been there.
Right. I mean, maybe it's a while loop, maybe an async event loop. But the point is, it's comforting. You know exactly what it's going to do because, well, you wrote the conditions.
Exactly. It's totally deterministic.
But what happens when you take that fundamental building block, like the core of computer science, and you inject it with a non-deterministic mind of its own?
That is where things get really wild.
Welcome to the deep dive. Tonight, we are pulling back the curtain for you, the software engineers out there who are building the next generation of applications. We are dissecting the core architecture running under the hood of every modern AI agent.
The agent loop.
The agent loop, exactly. And our mission tonight is to break down the stack of notes we have on the subject, specifically looking at a cycle of 4 phases. Observe, think, act, and evaluate.
Yeah, because the shift from, deterministic execution to autonomous iteration, it just requires a complete rewiring of how we even think about software design.
Right.
We're moving away from systems that just do what they're told and moving towards systems that figure out what to do next. And they do this based on a continuous string of feedback.
So, as developers, you and I are deeply familiar with loops. I mean, we write them every single day.
Oh, for sure.
But let's establish the baseline here. How does this AI agent loop fundamentally break from the traditional, execution cycles we're so used to?
Well, the real departure point is the shift from passive execution to active, continuous participation.
Okay, what do you mean by that?
So most developers first encounter large language models through a standard chat interface.
Right.
Prompt and response.
Yeah, like ChatGPT or whatever.
Exactly. Programmatically, that is essentially a pure function. You pass an input string, the model computes an output string, and it stops.
Right. It just waits.
Yeah, it waits indefinitely in a suspended state. It has literally zero agency.
So it's just sitting there until the user pokes it again.
Exactly. But the agent loop fundamentally alters that architecture by turning the LLM into a continuous engine.
Ah, I see.
Those 4 phases we mentioned, observe, think, act, evaluate, they repeat autonomously. They just keep going until a predefined task is actually complete.
Okay, so the observe phase gathers data from the environment, the think phase reasons about it, act executes a command, and evaluate decides if it worked.
Spot on.
My brain immediately maps this to like a classic computer science concept, the REPL.
Oh, yeah. The read evil print loop.
Right, every developer uses them. Node.js console, Python interactive shell. You type a command, it reads it, evaluates the syntax, prints the result, and loops back.
Sure. Very similar structure on the surface.
But looking at the evaluate phase in this agent loop, I kind of have to push back here.
Okay, lay it on me.
In a traditional REPL, the evil is just running the execution context. If I type 2 plus 2, it evaluates to 4. It's not pondering the semantic meaning of the math. So how does the evaluate phase in an agent loop work programmatically to make it uniquely dynamic?
That's a great distinction.
Ah.
The programmatic reality of the agent's evaluate phase is that it is performing a semantic assessment. It's not just a syntax check.
Semantic assessment, so it's looking at the meaning.
Exactly. Let's say a traditional Python script executes a command to scrape a web page. The evaluation logic is usually just a simple HTTP status check.
Right, like did it return a 200? Okay. Yes, keep going.
Yep. And if it returns 404, throw an error. But an agent's evaluate phase requires a much heavier lift. It asks, did the action I just took actually move me closer to my overarching goal?
Oh, wow. Okay, so it's evaluating actual progress, not just execution status.
Exactly.
But wait, how does that actually happen in the code? Does it just score itself?
Basically, yes. Mechanically, what happens in most of these agent frameworks is that the evaluate phase spins up a completely separate context window.
A whole separate window.
Yeah, you take the overarching goal, the state of the environment before the action, the specific action it just took, and the new observation, like the raw HTML of the page it scraped.
That's a lot of data.
It is. You package all of that into a brand new prompt and fire it off to the LLM. Or, honestly, often to a smaller, faster, cheaper model just for routing.
Oh, that makes sense for cost savings.
Right. And you ask that evaluator model to return a Boolean pass or fail, or maybe a confidence score out of 10, just based on whether the action advanced the goal.
So if the task is to find a specific company's Q3 financial report, right?
Right.
And the agent scrapes a page, the evaluate phase checks the raw HTML. If it's just a bunch of, I don't know, press releases instead of the actual SEC filing, the evaluation returns a fail.
Exactly.
Even though the code didn't break,
Yeah.
the HTTP request was 200 okay, but the strategy itself failed.
That qualitative assessment is the real linchpin of the dynamic loop. It forces the agent to actually change course. If the evaluator model returns a failing score, the loop doesn't crash. It simply uses that failure as the new state for the very next observe phase.
Well, wait, to evaluate a strategy, the system has to actually formulate a strategy in the first place, right?
Right, it can't just act blindly.
You can't evaluate whether you're closer to a goal unless you've done the computational work to figure out what that goal even requires.
Exactly.
Let's zoom in on the step right before the action, the think phase. Our notes talk about this leveraging the LLM's chain of thought reasoning.
Yes, functioning essentially as an inner monologue.
An inner monologue. See, from an engineering perspective, thinking here just means we're injecting a hidden system prompt, right?
Pretty much.
It forces the LLM to output its reasoning tokens before it outputs the actual command. So it's basically using token generation as a temporary scratch pad.
That's a great way to put it. And the mechanism of autoregressive text generation demands that scratchpad.
Why is that?
Well, large language models predict the next token based on the sequence of previous tokens. They don't have, like, a hidden internal memory to hold complex multi-step logic before they give you an answer.
Oh, right. They're literally just guessing the next word.
Right. So if you ask an LLM to solve a complex problem and demand the final answer immediately, it will frequently just fail. It lacks the computational space to work through the intermediate steps.
It's like asking someone to multiply two 4-digit numbers in their head instantly.
Yes, perfect analogy.
Versus, giving them a whiteboard to work it out step by step.
Exactly. And the generated text is that whiteboard. The agent transforms raw observations into actionable understanding by generating a text sequence that breaks the problem down.
So it literally writes out its thoughts.
Yeah, it might output something like, I see the web page is loaded. I'm looking for the login button. The login button is not in the main HTML body. I should probably check the embedded iframe.
That is wild. That text generation is the reasoning process itself.
It really is.
But, okay, how do we bridge the gap between prose and execution? If the model is just generating paragraphs of text about an iframe, how does the act phase know what to actually execute?
Right, because you can't exactly pass a paragraph of inner monologue to a REST API.
Exactly.
So framework developers solve this by enforcing really strict output schemas.
Okay, like JSON.
Exactly. You instruct the LLM in the system prompt that after it finishes its chain of thought rambling, it absolutely must output its final action in a specific format.
Like a JSON block wrapped in markdown tags.
Yep. And the framework uses standard regular expressions to parse the LLM's text stream, grab that JSON object, validate the parameters, and pass them to the actual Python or JavaScript function.
The function that actually executes the API call.
You got it.
Okay, so we parse the text, extract the JSON, fire the function, observe the result, evaluate the progress, and feed it all back in.
That's the loop.
But, and this feels like a massive engineering headache, if it is constantly generating text to act, and then evaluating that action, and then generating more text to plan the next action.
I know where you're going with this.
How does it know when to stop? It sounds like we are basically building the halting problem directly into our application architecture.
It really does. It's one of the hardest challenges in agent design.
I mean, in a more relatable sense, it sounds like dealing with a total perfectionist junior developer.
Oh, man. Yeah.
You give them a ticket, they submit a pull request, you approve it, but they immediately close it because they decided, oh, wait, I want to refactor the database schema.
And then they want to rewrite the CSS.
Yes, they just keep iterating and over-polishing indefinitely.
That over-polishing is a huge, very common pitfall. The perfectionist agent technically completes the task, but during the evaluated phase, its inner monologue decides the result could be slightly more optimized.
So it just kicks off another loop.
Exactly. And on the flip side, you have premature stopping.
Where it's
That's when the agent encounters a minor hurdle, say, a missing dependency.
right.
Gets totally confused by the error message and just declares the task fundamentally impossible.
Just throws its hands up. Can't be done.
Right. But the absolute worst-case scenario is the infinite loop.
Oh, I can imagine.
The agent takes an action, the action fails. It observes the failure, decides The best course of action is to try the exact same action again.
And it fails again.
Fails again.
Yeah.
And it just spins forever.
Just consuming tokens, maxing out rate limits.
And racking up a massive cloud bill the whole time.
Yeah.
Because, remember, an LLM is an engine built to continue sequences. It naturally just wants to keep generating text.
Right, so how do you stop it?
Preventing catastrophic looping requires moving the stopping logic entirely outside of the LLM's control.
Yeah.
You simply cannot rely on the model's inner monologue to decide when enough is enough.
So you have to implement strict programmatic budgets at the framework level.
Exactly.
We're talking about hard iteration caps, like a simple counter variable in our wrapper code that increments every time the loop cycles. And if iteration count hits, say, 15, we just throw a timeout exception and forcefully halt the thread.
Iteration caps, token limits per task, and rigid, mathematically defined exit conditions. You have to define what done looks like externally.
Give me an example of that.
Sure. So if the task is to extract 5 specific data points from a PDF, your wrapper code checks the JSON output. Once all 5 fields are populated and they pass type validation, the wrapper terminates the loop.
Regardless of whether the LLM wants to keep analyzing the document.
Exactly. Cut it off.
Okay. So we put external budgets in place to stop the loop from spinning out into the void. But what happens when the non-determinism manifests, differently?
How do you mean?
What if the loop doesn't spin infinitely, but instead just hits a brick wall? Like in the real world, APIs go down, auth tokens expire, DOM structures change overnight.
Oh, constantly.
Right. And in traditional engineering, we wrap our happy path in a try-catch block. If an unhandled exception gets thrown, the app crashes, the user sees a 500 internal server error, and someone checks the logs.
Yeah, but agent design requires a complete inversion of that mindset.
Really?
Yeah. Error handling is no longer an edge case. In agent systems, it is the normal operating condition.
The normal condition.
A well-designed agent operates under the assumption that most of its real-world actions will actually fail on the first attempt.
Wait. If the normal condition is failure, how do we handle a hard crash?
Well,
Say the agent tries to execute a SQL query on a database, right? And it gets a fatal syntax error because it hallucinated a column name. Usually that's an exception that stops execution entirely.
right.
Are you saying we are catching that exception, capturing the stack trace, and piping it back into the loop as a brand new observation?
That is exactly what I'm saying. The framework catches the exception, strangifies the stack trace, and just appends it to the context window.
Oh.
An error is simply new data. The agent observes the SQL syntax error. It enters the think phase, and its scratchpad might generate something like, I received a syntax error near the keyword where. The column userage does not exist. I should query the schema to find the correct column name.
That is insane. So it enters the act phase and executes a query to read the information schema instead of trying to pull the data directly.
Yes, it dynamically rewrites its own approach based on the exact error message it just caused.
That's brilliant.
It's the concept of graceful degradation and backtracking. If the agent gets stuck down a dead-end path, the framework maintains a history of its state. The agent can literally backtrack to a previous known good state, maybe 2 loops ago, and try an entirely different strategy.
So this malleability makes the agent resilient in unpredictable environments.
Exactly. Where traditional brittle code would just immediately shatter, the agent adapts.
But, and I got to play devil's advocate here, there is a ceiling to that resilience.
Yeah.
Even the most sophisticated chain of thought cannot logic its way out of a physically unplugged database server.
Very true.
If the connection string is dead, looping over the stack trace 50 times accomplishes literally nothing.
Just burns money.
Exactly. And if I'm an engineering manager, the idea of a non-deterministic loop constantly retrying failed actions and rewriting its own logic against my production systems, that is terrifying.
It's a nightmare.
I would need a way to intercept the loop right before the act phase to verify what it's about to do.
And that instinct is exactly why we have human-in-the-loop design.
Okay, human in the loop.
Managing agent risk in production relies on a principle called adjustable autonomy. You don't just deploy an agent with full write access and let it run wild.
Good.
You build a spectrum of control directly into the loop.
Ah, okay. It's exactly like managing access controls for a newly hired junior developer.
Yes, perfect analogy again.
Right. On day one, you do not give them the credentials to drop production database tables. You set up strict approval gates.
Right. They can write the code, they open the PR, but a senior engineer has to review every single line before it merges.
The junior dev cannot take a state-changing action without human sign-off.
Applying that to an agent system means implementing a full approval gate at the framework level. The agent runs its observe and think phases, formulates a plan, and generates the JSON command block.
But it doesn't fire it.
Right. Before the wrapper code passes that JSON to the execution function, it pauses the execution thread. It sends an asynchronous notification like a Slack message or an email or a dashboard alert to a human operator.
Detailing the intended action and its reasoning.
Exactly. And if the human clicks approve, the thread resumes and the action fires.
And if they click reject?
If the human rejects it and provides a text reason, the framework takes that rejection, treats it as new observation, and sends the agent back to the think phase to come up with a different plan.
Okay, that makes a lot of sense. So as the agent builds a track record of safe, accurate decisions in the system logs, you can begin adjusting that autonomy.
Exactly. You might relax the constraints so it can take read-only actions like running select queries or scraping public websites completely autonomously.
But you still require explicit human approval for any write actions.
Exactly, like updating a database record or sending an email to a client.
And then I guess eventually moving to fully autonomous operation for tightly bounded tasks, but relying on aggressive monitoring and anomaly detection to kill the process if it goes off the rails.
Adjustable autonomy is the only way teams can safely integrate dynamic agent loops into rigid enterprise environments. You offset the non-deterministic nature of the LLM with dynamic, programmatic supervision.
Man, we have dissected a massive architectural shift today.
It really is a whole new paradigm.
We mapped out the shift from writing deterministic scripts to managing autonomous loops governed by observation, thought, action, and evaluation. We dug into the programmatic reality of the evaluate phase, how frameworks spin up separate context windows to score semantic progress rather than just checking HTTP status codes.
Right.
We exposed the inner monologue, realizing that chain of thought is essentially a clever engineering hack.
Using tokens as a scratchpad.
Exactly. Before parsing out JSON commands with rejects, we tackled the stopping problem, reinforcing why we absolutely need external iteration caps and strict token budgets to prevent infinite looping.
Crucial for the cloud bill.
For sure. And we explored how agent loops invert traditional error handling, turning stack traces into actionable observations that trigger backtracking.
Graceful degradation.
Right. And we grounded all of this non-deterministic power with adjustable autonomy, ensuring that human approval gates stand between the agent's logic and our production databases.
But, the concepts we explored today, they're really just the engine.
Just the engine.
Yeah. An engine spinning in a void doesn't actually accomplish anything. The agent's ability to think, evaluate, and backtrack is totally meaningless if it cannot reach out and affect its environment.
Which sets the stage perfectly for tomorrow. We are moving from the architecture of thought to the mechanics of interaction.
Tool use.
Exactly. We are taking a deep dive into tool use. We'll explore how we physically wire these agent loops to external systems, how we map complex Python functions into schemas the LLM can understand.
And how agents authenticate with external APIs.
Yes, and how they execute code in sandbox environments, plus the critical security vulnerabilities introduced when you give a non-deterministic loop the actual keys to your infrastructure.
Gonna be a big one.
It is. But as you close out your IDE tonight, I want to leave you with a thought to ponder.
Okay.
We talked extensively about the framework code we write to manage the agent, right?
Yeah.
The regular expressions that parse its commands, the iteration counters that stop its loops, the error handlers that catch its exceptions.
Or wrapper code.
The wrapper code. But as these context windows grow to millions of tokens, and as these models become more capable of complex, multi-step reasoning, at what point does the inner monologue generated by the AI become more intricate, more robust, and more consequential than the actual deterministic wrapper code we originally wrote to govern it?
Wow, that's a heavy thought.
Something to keep you up tonight. Thanks for joining us on this deep dive. Keep building, keep questioning, and we will see you tomorrow.